So today we're going to talk about systems of linear equations. We know what linear equations are. These are equations that when you graph them, you get a what? Line. Now, when we say systems, it sounds kind of hard. It's really nothing more than you have more than one equations. So if you're talking about more than one equations at the same time, like 2, 3, 4 equations at the same time, that's what we mean by systems of linear equations. We'll get a little more into that in a minute. So there are many ways of solving systems of equations. Okay. Today we're going to talk about the simplest case, linear equations. One of the way of solving systems of linear equation is graphing method. Okay. That's why you need graph paper today. So let's kind of think back, and before we had like linear equations like this, either in y equals to mx plus b, right, form, which is called what again? Which form is this called? The name of this form is called slope-intercept. Good. This is really nice when you graph, right? Sometimes they give it to you in standard form, ax plus by equals to c. Now, if they give it to you in standard form, guess what you have to do? Yeah, make it into slope-intercept form so you could graph it, because since we're going to be graphing them. So if we're just talking about one line, you know, that's easy. How many solutions does one line have? Infinitely many. And when you plot all those order pairs, not the order pairs, what do you get? You get a line. That's why it's called linear equation. Now, so our solution was set of points that form a line. Remember? Okay, that's what we just talked about. Today, we're going to talk about then systems of linear equations. Okay, we're going to have now more than one. So guess what? Let's talk about the simplest case. Let's say that we have two linear equations. Okay. What do you think the solution of these two linear equation might look like? Oh, yeah, I see a lot of people still writing down. I'll give you some time. Go ahead, write this down. And think about, as you write this down, think about what it means when we have then two linear equations. What does it look like when we have systems of linear equations? This means simply two or more equations. Okay. So if the solution of linear equation is just a bunch of points that form a line, what do you think solution of systems of linear equation might look like? So as I said before, systems of linear equations, you have two or more equations in the same variable. Form a systems of equations. So write this down. I'll give you time. Go ahead. Write this down. And as you think about this, as you write this, think about what the solution of the system might look like. Okay. By the way, what do you think, guys? What do you think it means when I said two or more equations with same variables? What do you think what I mean by same variable? It really means nothing difficult. If one equation had x and y, guess what? The other equation is going to use x and y. It's not going to use a, b. You know what I mean? That's what I mean. Okay, so what do you think? So if I have just one line, you know that bunch of order pairs are your solutions, right? That form a line. What do you think then if I have two lines, what do you think my solution for the two lines might look like? Yeah, you have an idea?
Shared solutions.
Exactly. Say it again, louder. Shared solution. We're looking for shared solution. In other words, we're looking for the order pair that are solution for both of them. That's what we're looking for. Does that make sense? So it kind of narrows it down, kind of, doesn't it? If you have two lines. So what's one of the case? If the two lines, what can the two lines do when you have two lines? Yeah, they can cross, they can intersect. Guess what the intersection is? That's the solution. That intersection is where they share the same solutions, right? Right? That's the only place where that order pair is a solution for one of the line and the other line also. Does that make sense? Is that the only time? Would lines always cross like that every time? When you have two lines? No. What's another case? There are actually three. Yes, sir. Oh, did you have a question?
Yes.
Yeah. What was your question?
So it's about so is this gonna be on like the test or?
No. Yeah. So now one case is when the two lines intersect. What's the other case? Shirok, what do you think?
When like three lines intersect?
Well, we're going to talk about the simplest case where we're talking about two lines. Yeah, you could have 3 lines, 5 lines, 10 lines. But let's think about the systems of linear equations that's the simplest case will be just having two lines. When two lines, when you have two lines, the two lines could intersect. They could also do what?
Parallel.
They could be parallel. That's the second case. If the two lines are parallel, guess what? Do you think you have solution? No, because there isn't any order pair that is going to be solution for both of them. What's the third case? This third case is kind of a interesting one. Yeah. When they're perpendicular, that's a good point. That's kind of same as when they intersect. Very good. So that's a particular case when the two lines intersect. So it kind of goes into the first case. What goes with that first case? Can somebody think of the third case? If you have two lines, the two lines could intersect. They could be parallel. They could be also, Maddie? Oh. Yeah?
Inequalities.
Oh, that's actually next time. Yeah. Hold on to that thought. Yes? Can you have two solutions when you have two lines?
Oh, what if it says 2 or more? What if there's 3?
So I'm just talking about case of just two lines. Yeah. Well, and even with three lines, if you have two lines, you cannot have three solutions. The solution has to be true for all three. So yeah. So let's keep talking about just two lines. If you have two lines, yes, they could intersect. They can be parallel, or they could be. Maybe this is so obvious that you have. They could be same lines. Okay.
Oh, wow.
Yeah. So that's what. So here's some pictures. Okay. Sorry, maybe it was too obvious. So we're going to talk about the simplest case. So what do they look like, the solutions? Well, if they intersect, right, it's the intersection. Well, they don't always have to intersect. They could be parallel. Then there's no solution. And if they're the same line, then, okay, if they're the same line, what are your solutions? How many solutions do you have? Infinitely many. And what are they? Are they any point on the coordinate plane? No, because sometimes when I say infinitely many, they think, oh, then I could pick any point on a x and y axis. Would that be your solution? No. What would be your solution if you have infinitely many, when the two lines are same? So in case 2, what will your solution be? You're right. So, well, let's write this down. So case 1, how many solutions do we have? 1. For case 2, case 3, how many solutions do we have? None. What about case 2? We have infinitely many. Now, what are these infinitely many solutions? Are they any points on the x and y axis? No. What are the solutions? Where are the solutions? There are the, anybody? Well, I should write this down. Think about it. Oh, some of you already know. Think about this. I'll give you time. What are the infinitely many solutions? Which solutions are we talking about? Okay, go ahead. Think about that. Okay. As usual, write this. What do you think? Case 2. What are the infinitely many solutions? They're not anywhere on the x and y axis. Yeah. They're on the line. They're every point on this line, right? So not anywhere, but every point on these two lines where they intersect, because they're intersecting everywhere, right? So those are your infinitely many solutions. That's what we mean by infinitely many solutions here. Does that make sense? Because some people think that, oh, when they think it's any point. No. These are the points on these two lines, or, on this line, because they're same. Now, let's then think about these solutions in terms of their slope. Okay? When the two lines intersect, it turns out you could say something about the slope of those two lines. This is always going to be true. Well, let's do the easiest case. For case 3, when the two lines are parallel, what can you tell me about their slope? They are? Yes, they're same. Does that make sense? So that makes sense, right? If two lines have the same slope, then that's why they're parallel, right? And they can have, of course, different y-intercept, right? That's why they're parallel. What about case 2? When the two lines are same line, what can you tell me about their slope? They are? What? Same again. What about their y-intercept? They're same y-intercept. That's why they're same line, right? They have to have the same slope and the y-intercept in order to be the same line. Does that make sense? Okay, then what about the first case, where the two lines intersect? What can you write there in terms of their slope? Go ahead, think about this as a group. What do you think you could write there? Go ahead, I'll give it time. What do you think? What can you tell about the slope of these two lines? Okay, I hear a lot of people say they have to be, okay, who thinks they know what to write down there? Tali?
Different y-intercept unless it's on
Oh, okay. So we're talking about slopes, though. Let's talk about slopes first. What do you know about their slopes? You think they're gonna be different slope? How many people have different answer? Yeah. Do they have to be opposite? Not quite. I heard some of you say opposite reciprocal. That's only if the two lines are perpendicular. That's one particular case. When the two lines intersect, do they always have to be perpendicular? No. So you guys are correct. It is just different. That's all you need. Slope must be different. And what about their y-intercept? Do they have to have the same or different y-intercept? It does not matter. They could have same y-intercept or they don't have to have same y-intercept. Because when the two lines intersect, the y-intercept doesn't matter, right? It's really the slope. If the slope is different, then they're going to intersect. Okay? If this is true, let me ask you this. If one line has a slope of 1, the other line has a slope of 1.000001, so they're really, really very similar to each other. Will the two lines intersect? Caroline, why do you think they will intersect? You're right, they will. Even if they're slightly different, they will intersect. Why? Exactly. They go on forever. So even if they look really parallel to each other, if they're off just a bit, right? Since the line goes on forever, at some point, right, they have to intersect. Does that make sense? That's okay, good, very good. Okay, so I would like you to understand what we mean by the solutions of these linear equations, okay? Especially these two, when you have two lines. Okay. Any question? Does this make sense? Does this chart make sense? Do you understand what I mean by the slope? Yeah, question.
So like every line, if the equation's like different, they'll intersect.
Exactly. If you have two linear equations, okay, as long as they have different slope, they will always intersect. Even the one with slope equals 0 and the other is like undefined or something. They're different, right? They're gonna intersect. Okay. Because that's the case where it's one of them is horizontal, the other is vertical. You see what I mean? Very good. Any other question? Does this make sense? Okay. Good. Let's move on then. So some of you are asking, when the two lines intersect, what about their y-intercept? Well, y-intercept what? Does not matter, right? They could have the same y-intercept or different y-intercept. The two lines will intersect, right? If they have the same y-intercept, yeah, that's where the intersection is. But it doesn't have to be at the y-intercept, right? So anyway, so let's do a problem now. I'm going to ask you to do example 1. Solve the system by graphing. Here are the two equations. Y equals to x. The other, y equals to 6 minus x. By the way, when I ask you to solve using graphing method, do you think graphing paper will be helpful? Why? Why can't we just do it on a paper without any? Yeah.
Because like it helps you draw the line.
Yeah, it helps you be. It helps you to be really accurate, right? Because this time is really important that you draw them accurately, isn't that right? Because if you're slightly off, right, your intersection would not be correct. So anyway, so go ahead and write this down. See if you can do this for yourself. By the way, do you think y equals to 6 minus x, is that in the form that we like? No. You probably want to rewrite them as a what? Yeah. Which form do we like to write them as? Slope-intercept. Very good. Go ahead, everybody try and graph it on a graph paper, okay? I'll give you the time. By the way, I heard a good question. Do we need to draw them on a same x and y axis, same coordinate plane? Or do we draw them in separate coordinate plane? Same. Because if you draw them in separate plane, how are you going to look at their intersection? Okay, you need to draw them in the same plane. Go ahead. Okay. All right. We'll take a look at it together now. For the first line, y equals to x. What is my y-intercept? Well, what's my slope for this one? 1. Very good. What's my y-intercept, class? 0. Good. Okay, so some of you, I don't see any y-intercept. Well, that's because it's 0. Okay. What should we do with the second equation? I should rewrite this as y equals to negative x plus 6. And therefore, your slope for the second line is? What's the slope of the second line, class? Negative 1. What's the slope of the second line? I mean, y-intercept. Y-intercept is 6. Okay. Do we know how to graph them? Did you all graph them? Okay. All right. Let me graph it for you. Also. So as you can see, I kind of use different colors. I think it's a good idea because you can see the difference between the first one and the second.
Label them like line A and line B.
Yeah, you can label them line A and line B. Or actually, here's how you're going to label. I'm going to show you how to do that. So first of all, line 1. Where do I start? Since my y-intercept is 0, I start at 0. And since my slope is 1, I go up 1 to the right 1. You guys remember how to do that? Okay, so it's good to do a couple, not just the 2 points. So I'm going to connect them. Here you are, okay? And line 2, I'm going to do it. Oh, by the way, line 1. So the way you're supposed to label this is you're supposed to write y equals to x like this to the next, okay? So yeah, and then line 2, you start at 6. Let me do it blue. Your slope is -1, which means -1 over +1, or you could do +1 over -1, same thing. So you could go either down 1 to the right 1 or up 1 to the left. Doesn't matter. I'm gonna go down 1, and so here it is, and there. And is this? They don't intersect. Some of you do this. Sometimes people do this and go, "Oh, Mr. Huang, they don't intersect." What's wrong with this? The lines what? Go forever. So because your domain is all real numbers, right? So you need to extend this until they intersect, okay? And as you can see, and I'm going to label this y equals -x plus 6. And do you see my intersection? Right there. The way you're supposed to write the answer, you write solution of the system is, what is it, class? 3. In other words, 3 is a solution to the line 1 and 3 is solution to line 2. Is there any other point that is solution to both of them? No, that's the only point, right? That's why there's one intersection. Does this make sense?
Yes.
So it's pretty straightforward. You guys remember how to graph, right? So always turn these equations into slope-intercept form. It's a lot easier when you graph them, right? Are we good? Okay, can you do something like this? Another one? Like this? Okay, go ahead, try. Oh, before I get to the second one, let me write down what I just said. The solution of the system of 2 linear equation is the what? It's the intersection, but it's the order pair where it is, what kind of order pair? It's order pair where it's solution of the 2 lines or the both lines. That's what I wrote down. Okay, so write this down. This is the key concept of today. The solution of the system of 2 linear equation in 2 variable is an order pair, because you have 2 variables, x, y, that are true, or solution, for both equations. Okay. This is kind of summarizing what I just told you. Okay. So this is the key concept, like I said. Write this down. This is important. Because you have to understand what solution of systems of equations are. In this case, these were 2 lines, right? But what if you have a parabola in a line? How many solutions could you get if you have a parabola? Yes, at the most you could have 2 solutions. Is that the only case if you have a parabola in a line? You could have 2 solutions where the line hits the parabola twice. What other?
1.
You could have 1. When would that happen? Not only at the vertex, but it could kind of to the sideways too. So as long as the line hits the parabola once, then you get 1 solution. Is it possible to have no solutions if you have a parabola in a line? Yeah. When would that be? Yeah.
When the vertex, like one parabola, like the vertex is above the x-axis and then pointing upwards, and then the other is like opposite.
No, I'm talking about a parabola in a line. Yeah.
So the lines are down here, like below the x-axis, and then it drops way up.
Yeah, that's when the parabola and the line do not intersect, right? That's when you get no solution. That's possible, isn't it?
Yeah.
Does that make sense? So in this case, we're talking about the simplest case where you have 2 lines. But if you have a parabola and a line, it's maybe different. Anyway, you could also have parabola and a parabola. Anyway, that's a little later. Okay. Any question on what I mean by solutions of systems of equation? I just wrote down equation. I'm not necessarily talking about linear equations. Okay. It works for other equations as well. Okay. Now, if you understood that, then try this. Okay. Example 2. Solve system by graphing 2x minus y equals to 8, x plus y equals to 1. Do you think you should change them into slope-intercept form first? Yes. Okay, go ahead, everybody try. Help each other out. Okay. So, did you all get line 1 equals to y equals to 2x minus 8 when you write them as a slope-intercept form? And then the other one is y equals to negative x plus 1. How many people got the solution after you graph? Good. Sophia, what did you guys come up with? Yeah, so what's the solution? When you after you graph, where do they intersect? Good. 3, negative 2. How many people got 3, negative 2? Very good. Kyle, do we know that they're going to intersect? That we're going to have one solution? How do you know this? Exactly. You have different slope. You know you're going to, right? If you have two lines and if you have different slope, you know they're going to intersect at one point. And you're right, when you graph them like this, you get, see the yellow and the purple one? So there's your intersection, 3, negative 2. Okay? So I wrote down solution to the system is 3, negative 2. Because that's the only place where, it's true for both, right? It's solution for both of them. Any question? Just pretty straightforward. Let's do one more. Okay, go ahead and try example 3. It says 2x plus 3y equals to 6. The other one says 4x plus 6y equals to 12. Okay, go ahead. See what you get. Go ahead and graph and tell me what the solution is. Okay, Andrew, what did you do on example 3? You first did what?
I changed the first equation into slope-intercept form.
Good. And what did you get when you did that?
Y equals negative 2/3 of x plus 2.
Good. What about the second equation?
I did the same thing and I got the same answer.
Yeah, good. Don't they come out to be the same line? At first, they didn't look like they're the same line. What do you think that is? Yeah. Right, but if the two lines are the same, shouldn't the equation look kind of similar? Yeah.
Just one on the right is running left times 2.
Yeah. So it turns out they just multiply left side by 2 and the right side by 2. That's all. And once things are written in standard form, it's possible that even though they're same line, they don't have to look like each other. But once you change it to slope-intercept form, that's why we like slope-intercept form. You could tell that they're the same line. And so when you graph, how many solutions do you get? Infinitely many, you're right. And there you go. Don't you get this graph? And they're right on top of each other there, right? What are the infinitely many solutions again? Are there any points on these x, y axis? X and y axis? No, they're what? Every point on the line itself. Is that okay? Is that good? Any question? So every point, because that's where they intersect. Every point on this line is your solution, not anywhere. Okay, 0, 0. Is 0, 0 our solution? No. What about 1, 1? 1, 1 is, isn't it?
Yeah.
Wait, is it? No, not really, because you have to go. Yeah, no, it's not. What about 0, 2? Is that our solution? Yeah. Okay, there you go. Yeah, well, it doesn't hit 1, 1, does it? I think it's kind of above it. Anyway, does that make sense? Okay. Can I give you one last one now? Yes. Okay. Go ahead and solve by graphing. X minus 2y equals to negative 6. X minus 2y equals to 2. Go ahead, everybody try. Derek, what do I do for example 3? Can you tell me what to do?
Change x minus 2y equals negative 6 to slope-intercept.
Good. You want to change them into slope-intercept form? What do you get when you do that?
Y equals 1/2 x plus 3
Good. Y equals to 1/2 x plus
plus
3. Yeah, that's what I got. Good. Almond, what about the second equation? When you change it to slope-intercept form, what do you get?
Y equals 1/2 x minus 1.
Minus 1. It's very good. Now, just by looking at these two equations, you could see that they have the same slope and different. Matthew, what do you think our solution for this system would be? Yeah, what do you think you get no solution? Because they're parallel and yeah, they don't have y-intercepts. So they're two parallel lines, right? And they don't intersect, right? Did you all get this? Well, I haven't graphed it. So here's 3. What do I do at 3? So here's 3, and then I go what? Since my slope is 1/2, I go what, class? Up 1/2. And I could go down 1, left 2. Is that okay? Same thing here. And so when I graph, I get that. So do you think I should label it? Yes? Yes, you should. Okay, the second one, I start at -1, go up 1 to the right 2, and go up 1 right 2. As you can see, two lines are parallel. They will never what? Intersect. Okay. Oh, it doesn't look parallel. Hold on. Let me do a little better job. Here, okay. Y equals to 1/2 x minus 1. So, what do we write? The System has what? Has no solution. In other words, there is no order pair. There will be solution for both of them at the same time. Does that make sense? Is this clear? Any question? Pretty straightforward. Yeah, the rest of it is a review, isn't it? You just draw two lines instead of just drawing one, because we're used to drawing one. Good.